Hey, math friends. Okay, so today we're going to start a new unit representing relations. For the most part, kids find this particular unit fairly straightforward, so that's a good news. It'll be a good little mark booster for you. The confusing things are something called domain and range, where we have to really be careful of the specificity of how we write, how we communicate the domain and range, but that's a whole other lesson, and we'll talk about that. We'll deal with that together, so don't stress about that. The Other than that, most of what you're doing in this unit is really just interpreting graphs, and for the most part, I think you'll find it straightforward. So that's good. As way of introduction, though, now we're not going to do this activity obviously on video because, well, you're on video. But I want to describe the activity in a second. That's why there's this rope here. I want to describe what we would have done in class together, and then just talk to you about a little bit of vocabulary that we would have talked about afterwards. So first of all, a relation is a connection between two things, okay? You are related to your parents. There's some sort of connection between you and your parents. It might be a blood connection. It might be an adoption connection. It might be a love-hate connection, whatever it is. There is a connection between you and your parents, okay? And that's why we call that a relation. In math, relations are often a connection between some sort of group of numbers here with some sort of group of numbers here, and somehow there's some way of connecting those two groups together, okay? And that's what's called a relation. There are different types of relations as well as different ways to represent them, okay? So now, the tie the knot activity, I just want to give you a quick description so that I can debrief with you, even though you're not going to do it right now. Essentially, I would give you a string. I would cut pieces of string for you, and then you would measure the length of your string, and then you would tie a knot, and then you would measure the length of your string, and then you would tie a knot, and then you would measure the length of your string. And what I need you to see there is as you keep, I'm sure you can visualize this in your head, as you keep tying knots, the length of string would get smaller and smaller and smaller, okay? So the debrief of that would be describe how the number of knots and the length of the string are related. So that actually I just said, as the number of knots go up, the length of the string goes down because you need some of the length of the string to actually tie the knot. Would you connect the points on the graph? Explain why or why not. So what would happen is you would get a graph that would look something like this, where you would have the number of knots down here, and you would have the length of string here, okay? And you would go, and there might be a dot here where there's no knots. 1, 2, 3, 4, 5, 6, 7. Let's just do that for a second. If you had really, really good data, it would look something like this, okay? Where the length of the string is going down by a certain amount each time as you tie another knot. Now, would you connect the points in the graph? No, and this is a really important point to talk about, which is why I wanted to give you a little picture of it. You would not connect here because if you connected the points, let's just say I connected from there to there, you're saying all this data exists between this point and this point. And that's not true because that data in here would represent like 1.2 knots or 1.6 knots or something like that, okay? You can't have 1.6 of a knot. You either have a knot or you don't have a knot. So because of that, we can't connect the dots together. And that is something called discrete data. Now we're going to talk much more about that as we go on. But discrete data means that the points can't be connected together because nothing can exist in between the points, okay? Okay, what is the vertical intercept and what's the physical meaning of the vertical of this intercept? Now the vertical intercept, also known as the y-intercept, because this is the y-axis, it would be the point right here, okay? Now, for all of you, it'd be slightly different because you all started with a different length of string, but the coordinate itself would go bracket 0, comma whatever the length of your string was, okay? So it represents the initial length of the string, but as a coordinate pair, the y-intercept or the vertical intercept, the x value is always going to be 0 because I haven't moved to the left or right yet if I'm right on the right on the y-axis. So all of the coordinate points would be 0, comma, whatever that starting length for you was. What would be the approximate length of string with 15 knots? Well, if you had done this in class, most of you would not have gone to 15 knots. You would have only gone to like 7 or 8 knots. And so what you do is you look at the pattern and you just kind of pretend that pattern continues until you hit 15 knots and make a guesstimate based on the pattern that you saw, right? Because you would assume that that pattern keeps following as you keep doing knots. That's called extrapolating data. Extrapolating means you're looking at a point outside the data you have, but you're following the pattern to get to that point that's outside. What would be the approximate length of 5 knots, or the string? What would be the string length for 5 knots? So most of you would have had that in your data, so you would have just read it right off your data. That's called interpolating. Okay, so interpolating is when you are your data point is within what you've done, and extrapolating is when your data is outside of what you've actually done, okay? What do you know about all the possible values for the number of knots and the length of the string? And the purpose of this conversation is to realize there are restrictions on what these numbers can be. For instance, the length of string. Well, your string can't grow, right? So whatever your initial length of string is, it can't be larger than that. Your string can't disappear, so I can't have a negative length of string. Okay, I can't have a negative number of knots. So things like that, I want you to understand that there are actually real life restrictions on what these things can actually be, okay? Okay, so now, again, I know I've already stated this, but we're just gonna unpack this a bit more. So a relation is a rule that associates the elements of one set with the elements of another set. Now, what do we mean by a set? All we mean by a set is just a group. Okay, so we could look at my whole classroom, all the people in my classroom as one group, and we could call it Hill's Amazing Class of Math 10C, okay? And that would be the group. You, who are in my class, would be called an element of that set, okay? So the word element just refers to one item in the set. Okay, so I've given you a relation here, and I've given you a bunch of points that I've called x values, and I've given you a bunch of points that I've called y values. Your job is, can you figure out some sort of a rule that tells you how to go from a number in the x group to a number in the corresponding y group. Now, I want you to listen very carefully to what I said there, because a lot of you will look at this table, and if you were asked in junior high to describe what's happening, you might say, as x goes up by 1, y goes up by 5, and that's great, but you are looking at that data vertically. I want you to look at the data horizontally. So I want you to tell me, how do I go from an x value of 2 to a y value of 10? What's the connection there? How do I go from an x value of 3 to a y value of 15? What's the connection there? Okay, and most of you will figure that out very quickly. You're going to multiply x by 5 to get the y, okay? This is very similar to input-output machines that you would have done in junior high, if you remember that. I know lots of us block our junior high days out of our life. So maybe you don't remember what you've done in math in junior high, but you would have talked about input and output machines in junior high. So what other ways could we represent this relation? Okay, so think of other ways we could do it. Well, if I'm multiplying x by 5, another thing you might be comfortable with is actually giving me an equation. You would say y equals x times 5. But now we don't say x times 5 in math, we would say 5x. 5x means x times 5. Okay, so y equals 5x, that's an equation. That's another way to represent it. Okay, so what today is all about is how we can represent a relation in multiple different ways. If you're looking at this slide right now, I've shown you 3 ways already. I've shown you a table of values, that's what I gave you in the beginning. Then you gave me a description in words, multiply x by 5. And now we've given an equation, y equals 5x. Well, what else could we do with this table? This table becomes points, doesn't it? Like, don't I know I have the point 210 now? And I have the point 315, and I have the point 4, 20, and I have the point 5, 25. When I read those rows, they all are points on a graph, so why not graph it? Okay. Sorry, I have to get my mouse back there. So why not graph it? Okay, so it might look something like that when we graphed it. Okay, I'm just going to clear that. So now we have 4 so far. Okay, now before I keep going, I need to back up and just talk about set notation for a second, because the next thing I want to show you involves set notation. So set notation, remember set just means a group, okay? Set notation is a way of describing a set of elements. These elements get defined within set notation brackets, okay? So those are the squiggly brackets. I know I've said this in other lessons before, but your communication of math is super, super important. And the brackets that you choose to use mean something different. They all have a different context, okay? So usually when you give me brackets like that, that's gonna refer to a coordinate pair usually, okay? It also can refer to interval notation, which we'll talk about in a couple lessons, okay? But think about that as a coordinate pair. This is often used, it is used in interval notation, and it's often used as a transformation rule, okay? And then these guys, the squiggly ones, refer to a set. So we define a group using those guys. Now, students always get really stressed out when I say that the brackets matter, because they're like, oh, I don't know how to draw these guys. We're not looking for your artistic ability. We need to know that you understand it's the squiggly bracket, not the square bracket, and not the curved bracket, okay? So, for example, and we're gonna talk about what this means a lot in a couple days. We're gonna do this a lot more, but I'm just gonna read you the statement that says all the values of x such that, that's what that line means. If you recall when we talked about the rational family, we talked about that vertical line. X is a member of the real, is what this says. And it defines all the possible values of x to be anything that is a member of the real number family. Okay? So now why did I take a break and talk about that? I'll show you in 1 sec. There are 7 main ways to represent a relation. We've already looked at 4. The first 4 were the table of values, the words, multiply x by 5, the equation, and the graph. I'm going to add to that now an arrow diagram. Now, I don't know how much you guys remember about arrow diagrams. You should have seen some of these in junior high. The difference here between the arrow diagram and a table is that your input is the first guy here, your output is the second guy. Just like on a table, your input is the first column and your output is the second column. But they don't always match up horizontally like that. What happens is you put all your inputs in ascending order in the first bubble, and you put all your outputs in ascending order in the second bubble. Then you use an arrow to match up which input goes with which output, okay? Coordinate pairs or ordered pairs. Now this is why I needed to talk to you about set notation brackets. You'll notice here, I'm just listing all the coordinates, just like I got them from the table here in order to graph. I could have just listed the coordinates themselves and stuck them down here. Now, every coordinate is inside the coordinate brackets, so that's where you see the curved brackets. But then I want you to notice that the whole thing is in a set of set notation brackets, because we're defining the relation as this group of coordinates, okay? And then the last one to talk about is something called function notation. Function notation replaces y with f of x, okay? So it's gonna look like this, f of x equals 5x, instead of looking like this, y equals 5x. We're gonna talk about function notation tomorrow as its own lesson, so don't stress about that right now, okay? So what the purpose of today is just to make sure you're gonna get comfortable going from one type of relation to another, okay? I also need you to be very comfortable, if I just back this up once, in the table, your input is always stated first and your output's always stated last. In the arrow diagram, these are sometimes referred to as bubble diagrams as well. Your input is first, your output is last. Coordinate pairs, input comes first, output comes last, okay? So you always wanna make sure you're not mixing those guys up. Okay, so express the following relation in multiple ways. So this is a good time for me to be paused and you try a few, and then I'm going to show you what I did, okay? So what have I done? Well, I said I'm going to square x to get y. Okay, so that is representing it with words. I could say y equals x squared. That's representing it with an equation. I could list all the coordinate points. So again, each coordinate point is listed with the coordinate point brackets, which are just the curved brackets, but then all those points together are in a set of set notation brackets. I have represented it with an arrow diagram, and I'm going to represent it with a graph as well. Okay? Awesome. Next guy. So this time I started with an arrow diagram. Express the following relation in multiple ways. Now, it might take you a minute to figure out what this relation is describing. Have you caught it? You will when I show you the words. So we're looking at your output is the number of letters in the color word that is your input. So red has 3 letters in it, blue has 4 letters in it, purple has 6, and yellow has 6. Okay. I could also do that as a table. Okay, there is no equation to do for this one, right? Because we're not connecting 2 groups of numbers together. I could write it as coordinate pairs though as well. Okay. All right, how about this guy? Again, try and figure out what the relationship is. You're going to pause me. All right, so it seems that even numbers have an output of 10 and odd numbers have an output of 20. Okay, so that's one way to describe it is the relationship in words. I've given you coordinate points. I could give you a table of values, or I could give you a graph. All of those would be okay. All right. So that's kind of what we're going to work on today. This is your mission should you choose to accept it, and you have to. Have some fun with it. Make sure you're clearly communicating, and come see me if you have any questions. Okay? In the meantime, have a great day. Take care.